Here we have a quadratic inequality. We know it's that because on one side there's a quadratic expression and then we have an inequality. Now you're more used to seeing it with an equal sign, in which case it's not an inequality but an equation. And you know that to solve an equation, you are trying to find values of x for when the evaluation of this expression, x squared minus x minus 6, equals 0. So what we're trying to find with a quadratic inequality is values of x such that if we substitute them into that expression, x squared minus x minus 6, the result is greater than 0. Now you know that when you solve a quadratic equation, you get 0, 1 or 2 solutions. Okay? Now because we have a greater than sign here, we're looking for values that are going to create this evaluation being greater than 0. So the answer is going to be a range of values, which is going to have the inequality as part of it. Now, if we're trying to find values of x that are greater than 0, our first job is to find the values of x for when this expression equals 0. So essentially, we're going to solve it as a quadratic equation. Now, this in any exam situation will probably give you half the marks anyway. So if you're ever stuck, it's always a good fallback plan. So to begin, okay, we use our standard factorizing. I'll assume you know how to do this or you've watched the video, but we'd end up with x minus 2 now we're looking at x plus 2 and x minus 3, okay, greater than 0. Now, we need to solve these for the values of x themselves as though it was an equation. So although we've written a greater than sign, just assume it's an equal sign. So to solve this, we need this bracket to equal 0, because 0 times any bracket would equal 0. Okay, so here we'd find the value. X would have to be negative 2, because negative 2 plus 2 is 0, and 0 times the other bracket is 0 itself. And similarly for this one, we need a value of x that makes the bracket 0, so that would be x equals 3. So these are our two solutions for the quadratic equation x squared minus x minus 6 equals 0. Okay, and as I said before, that will get you half the marks probably at least. Now, to go any further, we're better switching from algebra to a geometric view, so a visual view of what we're trying to do. Okay, so if we look at our graph, we're going to draw a little sketch, and it will be awful because I can't draw very well. So we have x here and we have y here. Okay, it's the axes. Now we know 2 points on this expression, x squared minus x minus 6, are negative 2 and positive 3. So we can draw them in here. Negative 2 and positive 3. It's only a sketch, it doesn't really matter. Now, what we're looking for is values of x where this graph is greater than 0. Now, when we say greater than 0, if we were plotting it, we'd plot the graph y equals x squared minus x minus 6. But in terms of the expression, or the inequality, we've replaced y with 0. So what we're actually saying is, where is this graph above the x-axis? So its y values are positive. Now, to be able to do that, we need more points. We need all the points. So we need to sketch the graph of y equals x squared minus x minus 6. We have 2 points already, the roots or the solutions of the quadratic equation, minus 2 and plus 3. Okay, so what we need to do is work out what sort of graph it is. So here we should know our types of graph. It's a quadratic, so it's going to be a parabola, and a is 1 in this graph. So if you remember, for a general form, we have ax squared plus bx plus c, don't we? So in this one, we're saying that if a is 1, okay, that's going to make it a positive parabola. Or, as we like to say unofficially, a smiley face. Okay. So what we're going to end up with is a smiley face graph that comes down, cuts through here. Doesn't matter where it's going because it's a sketch, as long as we've got the general idea of what it looks like. Okay, now we want all the values for when this line, this smiley face line, if we move all the way along it, is greater than 0. So where it's above the x-axis. So there are two pieces where that's true. Here, it's above the x-axis. Here, it's on the x-axis, and then from -2 to +3, it's below the x-axis, gets to 3, where it's on the x-axis, and then when it's greater, it's up here. So they're the bits of the graph that we need to be able to define to find solutions to this problem. And you should be able to see that the graph, that is true for when x values go that way from -2, and when they go to the right or to positive, from +3. So our solution to this quadratic inequality is x must be less than -2, x must be greater than +3. And that's our answer. Now, you should be able to see that if this was a different question, so if this was the same quadratic, so say it was x squared minus x minus 6, but now instead of being greater than 0, it's less than 0, okay? We should be able to see how to do this. Again, we'd solve for the roots where it crosses the x-axis, so we've got that as -2 and +3. So we'll do our sketch again. So there's -2 +3. We know it's a positive parabola because a is 1, so it's going to do that because it's the same graph, isn't it? But we want it when it's less than 0. So there's the x, there's the y. So when is y less than 0? Less than 0 is this way. So where is the graph? If we move along the graph line, less than 0 or below the x-axis, and patently that is this bit here. Okay, so we can see that whereas the other one, there were two bits of the graph, two separate bits of the graph, we had two solution sets, x is less than 2, x is greater than 3. Here, we've only got one solution set, okay? It lies between -2 and +3. So our answer is going to be -2, +3, x, and then we're looking at a less than, so there. Okay, so that's the solution if we were looking for it was less than. All the values of x that lie between -2 and +3. So here we have a different example, an example of a negative quadratic inequality. We know it's negative because the x squared has a coefficient of -1, which we can see there. Okay. We also notice that this is a different type of inequality. The other one we did was a less than or greater than. This is a greater than or equals to. So when it's got an equals to on it, it means that the solution on the line, the x-axis, is also valid. Okay, so we need to take care of that when we solve it. Now, we do exactly the same thing as we did before. We're going to factorize. So first thing, take a factor of -1 out. So we've got a nice x squared plus 5x plus 4. Flip all the signs because we've taken -1 out. We've still got our greater than or equal to 0, and then we just factorize as normal. Okay, so there we go. So x, 1 and 4 plus and plus. Okay, so that should give us what we need. Solve it. So we come down here. So what makes this bracket 0 for value of x? So that's x equals -1. Down here, x equals -4. So there are our two solutions. Okay, so now we switch to the graph to give us an idea of what we're talking about. So here's our x and y axis, x and y. We've got a -4, -1 goes there. Okay, now it's a negative quadratic, so it's going to be a negative parabola or an inverted parabola. Common parlance, it's a sad face because it's negative. Poor graph. So we go way up here. Doesn't matter where it goes, but you know it comes back down there somewhere. Okay, it's just a sketch, just to help us. Now, we're looking for where this graph is greater than or equal to 0. So greater than or equal to 0 is where y is greater than or equal to 0. So this time, as I said, what's on the line on the x-axis is valid as well. So we need to be careful of that. So the only piece that's above it is this piece. It's a single piece. So we should remember from our last foray into this that it's a range. So it's above it between -4 and -1. There's the x. And this is going to be less than, but an equals now because we've got an equals in the inequality and an equal less than or equals to there. So all the values between and including -4 up to -1 give us our solution. Now be careful. Common mistake is people look at the greater than or equals to sign that's in the quadratic inequality itself and think that goes in the solution, but it doesn't. All the solution is a range of x values, and we always write ranges with less thans or less than or equal to signs. Okay, so don't confuse that. Now similarly, as we did the last one, if we flip this round, whoops, that didn't supposed to happen. If we flip this round, so minus x squared minus 5x minus 4 is less than or equal to 0, okay? We've got the same gumph here, so always down to there. Draw our graph. Okay, we know it's -4 and -1. There's where it crosses. It's a sad face, negative parabola, so it goes through, comes down. That's all. Let's get worse than the last one. But it's less than or equal to 0, okay? So where is this graph less than or equal to 0? Where is it less than or equal? Or where is it below the x-axis? Yeah, so it is below the x-axis when it's that way. So it's that bit, and it's that bit. So it's all x values going that way, and all x values going that way. So we've still got the solution. Critical values are, whoops, -4 and -1. Okay, -4, but this is x is less than or equal to -4, because as we said, -4 is a value that's valid, or we have x is greater than or equal to -1, and that's our solution for that one. Now, if they're trying to do your head in and give you something slightly more difficult, you need to just take control of it, okay? So here we have a quadratic inequality, except there's a quadratic on one side and there isn't a 0 on the other side. So the simple answer to this, let's make it 0 on that side, okay? So nice and easy. To do that, we just move the 2x and the plus 10 across the left-hand side, leaving 0 on one side. But if we move the terms across, the sign changes, so we just have to collect terms together. So we'd end up with x squared plus 3x negative 2x, okay? So that would give us x squared plus x, and take the plus 10 across, and that would become minus 10. So plus 4 minus 10 would be minus 6. It's greater than or equal to 0. And that's it. That's as hard as it gets. From there, you just do the standard that we did the last 2 pages, or a few examples, yeah? So factorize them out. Okay, so x and x. 2 and 3, we need a positive x, so the bigger number. Okay, so then we solve these, so we find out where they cut the x-axis. So in that case, x has got to equal 2, or x has got to equal -3. Okay, draw the graph again. Here we go. There's the graph. It's going to cut at -3, which is there, +2, which is there, x and y there. It's a positive quadratic because it's a plus 1 in front of the x squared term. So we know it's going to be a smiley face. It's got to be greater than 0. So greater than 0 is when it's above the x-axis, where the y values are positive. So it's that way. So that means it's this bit and it's this bit. Okay. So that means any x values that go in those 2 directions, which gives us the answer. X is less than -3, x is greater than 2. And that's how you solve quadratic inequalities where there isn't 0 on the other side. It uses a technique called transposition, but I'll do another video on that, where you're using one quadratic to try and solve another. Okay, I hope that helps. Bye.